So I think circles are included in this chapter just to kind of set up some foundational work for what we'll be doing later on, specifically with quadratic equations and their graphs, parabolas. But it also gives us a little more practice with doing things in the coordinate plane. And we make a connection to the very first section of this chapter, specifically the topic of the distance formula. Because as we're going to see, the equation for a circle, at least one form of it, is based on the distance formula. So here we have a definition. Circle in the coordinate plane, all right, is a set of points that are a fixed distance r, which is referred to as the radius, from a fixed point. And what we mean by fixed is that their values are the same. Okay, so the radius is the same throughout the geometry of the circle, and the points on the circle are based on a static point, right, or something that's fixed, and that's known as the center. And the center, generically speaking, is given by the ordered pair h comma k. And when a circle is in the coordinate plane, you can actually use the distance formula to come up with an equation that models the circle. And the first version of the equation is said to be the standard form version of a circle. At the bottom of the page, we'll look at what's called a general form. So we have a diagram, and to the right of it, we have the distance formula. So that's the version. This is the version of the distance formula that we encountered in the very first section of this chapter. And then you can see to the right of it that it's modified a little bit, where it's using the three variables involved in the definition of the circle. We have the radius r, the x-coordinate of the center, and the y-coordinate of the center. And where all that comes from is based on this diagram. If you look, we have the center h comma k plotted. It's at the very middle of the circle. And then there's a generic point on the circle with coordinates x comma y. If we wanted to examine the distance between these 2 points, we could use the distance formula. But because the point xy is a point on the circle, distance from the center to that point on the circle would be the same as the radius, which is why, in the formulas to the right of this, we're seeing d getting replaced by the variable r. You can think of the x and y coordinates of the point on the circle as an x2, y2 combo, and then the center of the circle as an x1, y1 combo. And so essentially, with the original version of the distance formula, x2 gets replaced by the variable x, and x1 gets replaced by the x-coordinate of the center h, which is why we have x minus h quantity squared with the modified version of the distance formula. And then y2 gets replaced by the variable y, and then y1 gets replaced by the variable k, which is why we have y minus k quantity squared in this modified version. Does that all make sense so far? Now, this modified version of the distance formula with the parts of the circle substituted in is not the typical version of the equation for a circle. Usually when we are referring to the standard form of the circle, we have the radical eliminated. And I'm going to show you how to do that real quickly. We can get rid of the square root by squaring each side. Okay, a topic we learned back in chapter 1. And by squaring each side, it eliminates the radical on the right. And here comes the official standard form of a circle. All right, I'm going to flip it, and I'm going to write the version without the radical. When the radical's gone, we're left with x minus h quantity squared plus y minus k quantity squared. And because we eliminated the square root by squaring each side, we have r squared on the right. All right, and that would be one version of how you can model the equation for a circle when it's in the coordinate plane. And usually one of the most common examples that follow up presenting the standard form is just to write the equation of a circle provided its radius and center. And that's exactly what we'll do in our first example. And then I'll go over the process on how you can graph a circle based on the standard form. Okay, so it says write the standard form of the equation of a circle. We have the radius 5 and the center at 2, -1, and then we'll graph it. So I want to note that its center provided in the problem is at 2, -1, and its radius also provided in the problem is 5. Now 2 is a particular value of h, and k is -1 is a particular value of k. So what we do is we fold both pieces of information into the standard form. In the first set of parentheses, it's going to be x minus our value of h, which is 2. We'll close off parentheses and square, plus open up our second set of parentheses, y minus our value of k, which is -1. Close off parentheses and square, and then we take our radius 5 and square that. From here, you just want to simplify any double negatives, which we have double negatives in our second set of parentheses, and typically the radius gets squared out. So you would more often than not see this answer written simplified in the following way. Okay, and that would be our equation of the circle with that center and that radius. Now to graph, I'll break this down in 3 steps. Okay, the first step is to plot the center h comma k. The second step is to use the radius, so I'll say use r to generate 4 points, and these 4 points would be on the circle, and I'll show you how to do that in just a second. And then the third and final step is my favorite part, where you connect the 4 points in a circle. So our center is at 2, -1. Well, let's plot that point. We'll start at the origin. We'll go 2 spaces to the right and down 1. And there's our center. Our radius is 5, so since this is our center, all points on the circle are going to be 5 units away from this. So with regard to step 2, use R to generate 4 points. The easiest 4 points to get are those that are above, below, and then to the left and right of the center. Kind of like a Mortal Kombat cheat code, up, down, left, and right. But anyway, what you do is you start at your center, which is at 2, -1. And since our radius is 5, I'm going to go 5 units above it. And it might help to label that point just for reference. That would be at 2, 4. We'll go back to our center and go 5 spaces down, which that would be at 2, -6. Go back to our center, go 5 spaces left. That would be at -3, -1. And then go back to our center and go 5 spaces to the right. And that would be at 7, -1. Everybody good still? So we'll go ahead and connect all these points in a circular fashion. Let me re-emphasize the 4 points that we got from our radius. And there would be our graph. You don't have to do this, but I like to sometimes, just for perspective. I'm going to connect the center with one of these 4 points and just indicate that the radius helped us generate these points and had a R value of 5. And maybe while I'm at it, now that I'm thinking about it, we'll put the coordinates of the center, which is at 2, -1. All right, and that's really all there is to it in terms of writing the equation of a circle in standard form. Okay, once you have the radius and center, just plug them in, simplify if possible, and then to graph it, just plot the center, then use your radius to generate points above, below, to left and right, and then just connect the 4 points, with the circle as best as you can. And it's definitely a no judgment zone on sketches of circles. All right, I know it's not the easiest thing to do, so don't feel ashamed about the circles you draw. I can promise you I've drawn worse. All right, so there's one more form of a circle that we want to be aware of, and that's the general form. And the general form of a circle is essentially what we get when we square out the expressions x minus h and y minus k. We can square those out and reorder the terms in a special way, and the end result is an equation of this format where it's x squared plus y squared. Sometimes there's a term involving just regular x, so we would write that afterward. If there's a term involving just regular y, that follows it. And then any numbers without variables get combined and they form the tail end of the expression on this left-hand side. On the right-hand side, we force that to be 0. So let me show you how this is done with this upcoming example. Here we have the standard form of a circle, and maybe it might be a good idea to try and figure out what the center and radius of the circle is before we do the standard form, or general form, I mean. I'll show you a trick for finding the coordinates of the center if you have the equation provided. You just think opposite. So for instance, in the first set of parentheses, we have -2. What's the opposite of -2? +2, okay? That would be the value of h. What's the opposite of +1? -1. So our center would be at 2, -1. Now the radius is based on the number on the right-hand side. Notice that this doesn't have a power of 2. What that means for us is that the radius has already been squared out. So to find the radius, if that's missing a power of 2, we square root the number. Okay, and the square root of 9 is 3, which is why the radius of the circle would be 3. Okay, does that make sense, folks? Alrighty. So general form, though, is on the docket. And this is really quick to do. Essentially what you do for standard form is you do a couple of rounds of FOIL and then just rearrange the equation so that it matches what's in the box. So with x minus 2 quantity squared, it's 2 factors of x minus 2 being added to 2 factors of y plus 1 equaling 9. So let me give you a moment to FOIL each set here, and then I'll show you what to do afterwards. All right, so we're looking at x squared minus 4x plus 4, and then y squared plus 2y plus 1. Sweet. Okay, so now that that's all FOILed out, we'll do our best to rewrite this equation in the general form format. Keep in mind, we have x squared and y squared in our problem, so we'll lead off with both of those, x squared going first. We do have a term involving just regular x, that's minus 4x. We'll write that next. We do have a term involving regular y, that's 2y. It's positive, by the way, reason for plus 2y. And then we have a couple of numbers that we can combine as well on the left-hand side, 4 and 1 to get positive 5. One more thing to do, though. Any ideas what that might be? Subtract 9. Yep. And this would be our general form of the circle. Okay, any questions, comments, concerns, winning lotto numbers on this one? All right. So I think we're probably about due for a break. When you come back, talk about our last example here. Maybe pitch an idea to you folks about it. And we will take care of the very last section on variation. All right, so I'll see you guys soon. See you in about 5 minutes. All right, folks, welcome back. You guys ready to rock and roll? So what I'd like to do with last example is send out a solution video. I have one already made for this one, which helps you convert an equation in general form to one that's in standard form.